Hello and welcome back. In this episode, we are going to add a little bit of. We're going to fake a little bit of movement in the y axis for these ships. It still is a 2D game, but I want to break things up just a little bit so things aren't perfectly flat, or we have options to have ships maybe move around a little bit in the height. So, if you'll notice here, we have a parameter called vertical speed, and it's a little bit different. It's different from our maximum speed variable, and this is basically how fast will the unit move on its y-axis, so up and down. So I'm just going to go down here, and I've created a new region called height movement. And the first thing I'm going to do is I'm going to create a new coroutine called height move. It's going to take a target height value. And of course, with my coroutines, the little coroutine pattern I like to have, I like to create a public coroutine class called height move coroutine, so that way we keep track of the current running coroutine. So in case there's a new change of movement, we can detect if it's already moving in a certain direction and cancel that if need be later. Alrighty, so first thing we're going to do is I'm going to create a parameter called current graphics height, and that's going to, we're going to, one more thing I might have forgotten to mention is that I'm creating a required component. Required will force the user to drag and drop the graphics transform game object, thanks to the purchase Odin inspector, which I bought recently. And so we're going to take the graphics. Remember, the graphics is everything that is containing, or that is holding, is a child game object that's holding all of the mesh of the unit. So all the parts that are going to move with the actual, on the actual ship, that we have separated from the selection indicator, because the selection indicator is going to have its own little movement, a little different from the ship itself. So we're going to take the local position. So a local position is a little bit different from a world position. It's going to be relative. It's going to be basically the displacement of the graphics child game object from its root parent unit game object. So if it's the exact same spot, if it's in the exact same spot as the root unit game object, its local position is going to be 0, 0, 0. So this is a relative position to where the unit is. And remember, the unit is what is actually the root unit game object is what is actually moving along the path, and this is going to be like a smaller little part of that's going to be moving up and down. That's going to be important. It's kind of an important concept to see here. So just to show you, here's our ship root game object, and then inside there is the child, and you'll notice that its position is 0, 0, 0. And now if I go look at one of these ships, the Akira's, it's the root unit game object is at position -2, 0, 2.56, and its graphics are kind of slightly. This is a local position, not a world position. The world position should look a little something more like this. It's not. If it 0, 0, 0. Let me just type this in. Is actually here, and that's not where it is. So just a little bit of a distinction here that these are in local coordinates. Okay, so let's get back to it. So we're storing the local position of the graphics. So the graphics right there. And then the next thing we're going to do is we're going to figure out what distance are we height-wise from our target height. And I'm just going to subtract the current graphics height from the target height and just do an absolute value there. And the first thing I'm going to do is place the root unit object at a height of 0 without changing the location of the graphics child object. So I want the, in the past I've had problems with moving the height for some reason with the root unit object for some reason just shooting up into infinity for some unknown glitch. I probably was a coding error, but this is how I solved it. So basically what I'm going to do is I'm going to make sure at the very beginning the unit, the root unit, remember, okay, that would be like this. The root unit game object is at a height of 0. I want that to stay flat on the board, on the grid. And so the first thing I need to do is I have to create a new height 0 position for the unit object. So the first part of that is to get the position of the unit game object. And remember, the engine script is on that root unit game object, and so it's just equal to the position of the transform position. And so now I'm going to take this value here, and we're going to zero it out by, guess what, taking the y parameter and setting it equal to 0. And so now I kind of want, if I move the parent root unit game object, that's going to move everything with it, including the graphics. And I want this to move without it appearing like the ship moved. So we're going to store the graphics position in this variable here. And then we're going to take we're going to move the root or the unit game object to the new zeroed height position. And when that happens, since it's a child, the graphics is going to move with it. So what I'm going to do is, since I've stored the position before we moved the parent, we're going to now take this child graphics object and put it back to where it was. So it should be so instantaneous that the user doesn't notice that the graphics moved and then moved back. So now we're ready to kind of go and do our proper coroutine stuff here. And basically, while the distance to that target height is greater than 0, remember, it's the absolute value. So while we're not at the height that our goal height here, our goal target height, it's going to run this coroutine. And the first thing we need to do is we need to create a couple of vectors to slurp between. Remember, slurp from the last video is just how to interpolate between two positions. And so I'm going to store the current graphics position again, and it's going to equal graphics.localPosition. And then we're going to create a target graphics position. And remember, we're slurping the graphics component too. So it's the graphics that we're moving in height, not the unit root, the root unit, the parent / root unit game object. That is staying flat at height 0. It's the graphics that we're going to move up and down, because that's just how I'm choosing to fake. I mean, it definitely has its own height 3D value, but the pathfinding is all going to be 2D. Even though the graphics of the ship can be raised up or a little bit down, it's still gonna, the RVOs and the avoidance is still gonna act 2-dimensionally. So we have our target graphics position here, and that's gonna equal a new vector 3. It's gonna be equal to 0. We're dealing with local here, and then the target height, and then 0. But I still, like, maybe before, when we set up the graphics, for some reason, maybe the meshes of the ship are just kind of in a weird position, and where I have it centered in for the ship, maybe the X and Z values might not be 0, so I don't want to lose that, where I might have set that up for a particular unit. So I'm going to store that target graphics position X equals current graphics position dot X. So we're not going to change the position at all of along the X or Z axes. It's going to stay the same. We're just playing with height here, so we're saving those values, and we're for the target. We're not, our target's position is not going to be any different in the X and Z axis from where it currently is set up to be. And then now we can slurp between those two positions. So first thing, we put in where it currently is and where we want it to go, and then kind of a progress value, which we determine by how much time, fixed time, has passed since the last frame, multiplied by that vertical speed value that's been there all along. And so now I'm going to find the difference between, okay, so we'll move it there, And then now I'm going to set the current graphics height. Remember, this was first created up here, and it's, yeah, there we go. The current graphics height to where we just moved it to. So the position was changed here, and now we need to update our current graphics height parameter, and I'm going to now update what is running, the variable that is being checked for this while loop, to take into account where we just moved it to. So the distance is now changed. We should have gotten closer. So distance to target height is going to equal mathf, so the absolute value of our goal height, or sorry, where we currently are, minus the target height. And yeah, eventually it will go to where it needs to be, and it will be 0. And then we can do our typical coroutine thing. Without it, the coroutine will be very mad. With it, this is required of all coroutines, a yield return null. Okay, we're going to keep coming back. This is going to come back at the next frame. Come back at the next frame until our goal, we've reached our goal. The distance to our goal is 0. And then we can set this coroutine, this height move coroutine, the thing that we're keeping track of, a current coroutine, equal to null. And here we go. We can do a little check to make sure before we start a new height coroutine there already isn't one in running. That's what this is for, again, to keep track of if there's currently a height move coroutine going. And if there is, let's stop it and then set it equal to a new one. And we're going to send coordinate.y. So we can now pass 3D coordinates, and the pathfinding will take care of the x and the y, or the x and the z, but this coroutine will take care of the y part. And if we just go to the selection manifest in order to test this out, I'm not sure if this is how it's actually going to work in the final game, if it's going to be completely up to random chance, or maybe if the user will have a say in the height. But I added to the individual destination, I changed the y to between a random range of -5 and 5, so it adds a little bit of height variation. And then we just can, you know, once again, in our selection manifest for our move fleet, that's where we are. Sorry if I didn't give you some context there. But essentially, yep, we're just going to pick a random height to send each unit to, and have each of the engines call the set course function, which goes here, starts that. So let's go check out our game. Okay. There we go. Each one of them is going to their own little height here. And if you'll notice, these cylinders here represent our pathfinding on the unit, the parent object. But our graphics have been moved up and down. Okay, that's a bad example. It's not moved very much. Here we go. The graphics are all the way down here, but should we move it all the way up, it would be right back to, oh, nice. Okay, it's moving it back for us. Now, it might not ever completely get exactly to 0, so we might want to just say, hey, at 0.05, call it good enough. Now, if you were noticing, the selection indicators were doing some funny stuff there. If you'll notice here, the selection indicators are flat, and it gets if the height difference is too much, it gets a little bit hard to tell where what it is we're selecting, you know. So I kind of want this indicator to move with the ship along its height, the graphics. And I also want the Starfleet insignia to kind of always be rotated in a way so that we see it facing the camera. So let's do that. In the UI logic folder, I'm going to create a new C# script, and I'm going to call it selection indicator. And I'm going to make sure that we're using Cyrenix.Odin Inspector. Give myself some space. Create another variable to transform graphics to drag and drop, and we're going to do required. And we're going to do serialize field. Now I'm going to do a void on awake. Actually, let's make that on enable. I'm going to create a float. I'm going to call it graphics offset. This is going to be the, better yet, instead of a float, we're going to call it a vector3 graphics offset. And when we first enable, we're going to make the graphics offset equal to the difference of the graphics local position from the selection indicator's local position. And instead of on enable, I'm going to do on validate. And lastly, we're going to use the built-in late update function, which is going to occur after the update has gone through. So it's really good for timing that we move this after other stuff has happened. So after the camera's moved, after the unit itself has moved. So it's just, the late update is just something that it's really good for something that you want kind of maybe tracking onto some other thing that's in the update function, which will come earlier. So we're going to check, first of all, if the mesh render, which basically is what's going to be, is basically going to tell us if the selection indicator is on or is visible, which means that we're selected. Then we're going to do a couple things. I'm going to take the transform.local position, and it's going to equal the graphics.local position plus the graphics offset. Selection indicator, we're going to find the selection indicator here, and we are going to just drag and drop it into place. And note that it's yelling at us. It wants us to drag and drop the graphics. Perfect. And what do you know? When it goes to a new height, the selection indicators follow based off of that initial offset. I'm going to want to get access to the camera information, or what the position of the camera, so I'm just going to do that and find the transform component on the camera. And so remember, I'm going to find the camera controller, singleton.get main camera. That's going to get us a, that's going to get us a transform already. So we can just save the redundancy there. The first thing we're going to do is we're going to determine if we're at or above the grid, or if the camera is at or above the grid. Well, then we're going to want to take the selection indicator, going to set its world rotation to, which takes a quaternion. We're going to set it to 90, and then c dot Euler angles dot y. So the heading or y-axis rotation of the camera, and then 0. And it looks like I have a little bit of a typo here. My bad. This needs to be dot Euler. And we can get rid of that. And then when we're below the grid, we're gonna make sure that the x-axis that we're flipped to 180 degrees, 90 plus 180 is to 70 degrees. We're going to be flipped because we're looking at the at everything from upside down. And so yeah, we're just going to flip things over so that way it's still facing the front of the selection indicator is now going to be flipped upside down because the camera is now below the grid. So it will still look right. So now let's just check to see what this does. I'm going to select these units, and notice how regardless with how the ship's rotating, the selection indicator is staying straight relative to the camera. And now if I move the camera around, it's going to rotate with us. How cool is that? And if we go below, there we go. I think I'm actually going to, rather than make it be below the plane, make it be below the ship. So graphics dot position dot y. So if the camera is above the graphics, then we'll do that. Or actually, rather than the graphics, selection indicator. So we'll just do transform.position.y since this is the selection indicator script on the selection indicator game object. Let's try that again. Here we go. So we'll move down, and did that one flip? I think so. Yep, they're flipping. Yeah, perfect. If we've done our job right, it's hard to tell. All right, I think that's good for this episode. I'll see you next time.